Hi everyone. I'm totally excited about making this video because it's not every day that you get to witness a big breakthrough in elementary math. Okay? It's a brand new way of solving the quadratic equation. Yeah. Right, so this brand new way is not only new, it's better. From my point of view, it's better. It's easier to do. It's easier to understand where it came from. To me, it's better in every way. And it's brand new. It was just posted online by Professor Po-shen, who is a professor of mathematics at Carnegie Mellon University on October 16. So as of today, it's less than 2 months ago. It's like a month and a half ago. Yeah, and the reason why it's so exciting is because humans have been solving quadratic equations for like several thousand years since Babylonian time, and using the modern notation, the kind of notation in math that we're using now, we've been solving it with the quadratic equation for something, I want to say 500, maybe 400, but definitely a lot of hundreds of years ago, and nobody thought of this particular approach. So that's why I'm so excited about it, and I'm so happy I'm able to share it with you. So without further ado, let's take a look at how we solve a quadratic equation. All right? So first of all, if you're given an equation ax squared plus bx plus c equals 0, then our first instinct, especially here in the US, is to try to factor, okay? And when factoring doesn't work, then we move on to the quadratic formula. Now, the quadratic formula, on the one hand, is your best friend because it can solve every quadratic equation ever. You throw a quadratic equation at it, and it will solve it, okay? It's not like factoring where you have a lot of times where you have seen it. Okay, you have seen situations where you try to solve using factoring, you can't. Okay, quadratic formula doesn't have that problem, but it has the opposite problem. It's so powerful, but it's hard. Okay, people have to come up with like stories about negative boy, couldn't decide whether to go to radical party, blah blah blah, or they have to come up with a song and sing to it. So you can get negative b plus or minus square root b squared minus 4ac over 2a. And the first few times you did it, and as a math teacher, I've seen this with my own eyes multiple times. The first time people carry out the quadratic equation, it was hard. I had to keep track of what is a equal to, what's b equal to, what c is equal to. You plug it in, and the order of operation, the whole PEMDAS thing messed people up, okay? And the biggest problem is, especially once you've got a little advanced, then people try to explain to you where the quadratic formula came from. You're like, oh, really? Completing the square. And I can tell you, a lot of my teachers, a lot of my students, even some of the good ones, are scared of completing the square. They're like, I will give an exam, lots of different problems, and they will try them all. But there will be students who will try them all except for the completing the square problem. So I know it's kind of scary. And that's the downside of the quadratic formula. It's so powerful, but to carry it out is hard. And to understand where it came from, you have to understand something even harder. So enter a math professor of Carnegie Mellon University, Professor Po-shen. Okay, he provided this new method, and he describes it in his abstract. You can pause the video to read it if you want, but I agree with what his evaluation of his own method there. That is very little computation, and it's conceptually natural. It deals with the graph of the quadratic and the fact that, average and all that, but you'll see. So first, let's take a look at a simple example, okay? Let's say you're given x squared plus 6x plus 5. Yeah, I said simple, but yeah, it's not like the most simple, but here's it's simple enough, okay? Because it's something that you can factor, okay? You look at this equation, you say, I'm gonna look for two numbers that add to 6 and multiply to 5, okay? And for most people, and since you're here, I might as well tell you, when you're trying to factor quadratic, look for the two numbers that multiply to C first, okay? Oh, and by the way, I said C because this is very conveniently, there's no A terms here. So it's starting out with X squared. That's the kind of thing we like, right? We like to factor equations that don't have an A in front or has A equals 1. All right, so anyway, so we look at the product first. Okay, you concentrate on that because there are fewer answers there. What two numbers multiply to 5? Either +1 and +5, +1 and +5, or -1 and -5. Okay, so between those two pairs, which one has a sum of 6? The +1 and the +5. So the two numbers are +1 and +5. You use those two numbers in your factor, x plus 1 times x plus 5 equals 0. You get the roots are -1 and -5. Done. Okay. Good, yeah? Now, I'd like to point out something. When you're trying to factor, you look for two numbers that add up to +6. You look for two numbers that add up to b. Okay, but by the time you solve, the two roots are -1 and -5. The two roots are the opposite of the two numbers you use to factor. Yeah? Okay, and therefore their sum will also be opposite. Okay, the roots of the sum add to -6, not 6. The two numbers used to factor add up to 6, but the roots themselves add to -6. Okay, so here's the rule. The rule is when you have the equation x squared plus bx plus c, the roots will add to -b. Okay, that will be important in a minute. All right, now let's make it harder. Let's change that number 5 to a 7. First instinct, let's think about factoring. Two numbers that multiply to 7 add to 6. Either 1 and 7, that adds to 8, that doesn't work. Or -1 and -7, those add to -8, not 6. So those don't work either. Some of you may say, wait, how about 7 and -1? Well, nice try. 7 and -1 add up to 6, but they multiply to -7. And we're looking for +7. All right, so yeah, we have two choices, -1 and -7, +1, +7, and they don't work. So we can't do it. If we can't do it, we have to, guess what? OMG, pull out the quadratic formula. Maybe not. Okay. All right, so here's Professor Lowe's approach. All right, think about the graph of the function x squared plus 6x plus 7. Let's say that it has two solutions here and there. Those are the roots, right? Then we know something about these roots. We know that they add to -6, and we know they multiply to 7. So first we know they add to -6, okay? And the two roots are on the two sides of the parabola like this. So they're symmetric. They're symmetric across this number here. And this value here is the average of the two roots. Okay? Yeah, with me so far? So here's Professor Lowe's first light bulb. The first light bulb is this, that there's an average here. And what's the value of that average? If the sum, if the two numbers add up to -6, then the average is -3. Yeah. Okay. So here's his first big light bulb moment. We don't know where the roots are. There's one here, there's one there. We don't know where they are exactly, but we do know that they add up to -6. And if two numbers add up to -6, then the average value of those two numbers has to be -3. So that means this part, this place, this location right here is -3. And we don't know what this distance is between the two points and the average, but we know that this distance and that distance are the same distance. Okay, so if the middle is -3 and the first root is there, then we can call this some letter z plus some letter z. So from -3, you add a z, it goes to the first root, and you subtract the z, it goes to the other root. Okay, so we don't know what the two roots are equal to, but we know that they must be -3 plus some z for one of them and -3 minus some z for the other. Okay, so that's the first light bulb. Okay. So and you're like, okay, how does that help? Okay, it's interesting, but how does that help? Well, so far we've used the fact that the two roots have to add up to -6. Well, Professor Lowe has another light bulb moment. Okay. His second light bulb moment is, well, the product of the two roots has to be 7. Okay. And so let's use that fact. We know the two roots must be -3 plus z, and the other must be -3 minus z, so the product of them must be 7. So I have -3 plus z on one side. -3 plus z is here, and have -3 minus z over here. And they are the two roots, so they must multiply to 7. So 2 light bulb moments, and we get a new equation. The new equation is -3 plus z times -3 minus z equals 7. Ha! And you're like, how's that supposed to help me, right? Especially if you're familiar with quadratic formula, you know that you're going to have to multiply this out, move the 7 over, and you're thinking like, I'm not sure if this helps. I'm just exchanging one equation that's kind of bad with another equation that's also kind of bad. And this is Professor Lowe's third and most important light bulb. His new light bulb moment is this. This is the formula for difference of squares. Okay, you have a plus b times a minus b. That's the formula for the difference of squares. So if you multiply this out, okay, a plus b times a minus b is a squared minus b squared. Okay, so if you multiply out the left side, you get -3 squared minus z squared. Okay, so basically you got 9 minus z squared equals to 7. So yeah, it's a much easier equation to solve than your original quadratic, because there isn't a z term. There's just z squared. So you can just solve it by first solving for z squared. Subtracting 9 both sides, you get -z squared equals -2. Z squared equals 2. So z is equal to plus or minus square root of 2. Actually, since we define z as a distance, it's just the positive. It's just square root of 2. So yeah, in a way, you don't even need to know about the plus or minus square root. You just go square root of 2. So remember this. We now know what z is. So the solutions are, one is -3 plus square root of 2, and the other is -3 minus square root of 2. So the roots are -3 plus square root of 2 and -3 minus square root of 2. Ha! Done. Yeah. Right? Right? Isn't that cool? No quadratic formula. Okay? No quadratic formula. And you don't need to understand completing the square to know how I got my solution. I got my solution from the fact that the sum of the two numbers is equal to b. Sorry, negative b, and therefore the average of the two numbers is negative b. Okay? And what's also cool for me is that it reinforces your knowledge of different squares. And as an educator, as a math educator, I really want you to understand the difference of squares. I really want you to know how to work with the special factors, the difference of square, the square of a sum, the square of the differences, etc. Okay, so yeah, that's why I think it's so cool. Right? Right, so you can run through the video again to see how it works, but I'll summarize it here. In summary, first of all, given an equation, x squared plus bx plus c equals 0, then the first thing we notice is that the sum of the two roots is negative b. So the average of the two roots is negative b over 2. Okay, so it'll be that number in between those 2 points on the parabola. Okay, so first you compute that number to see what's equal to. All right, now you know that the product of the two roots is c, so you set that at that equation. Okay, the first part of the equation is the first root, the average, plus some number z, and the second number is the other root, the average, minus some number z. And this average you got out of negative b over 2, so it's an actual number. Okay, so there's a numerical value here, there's a numerical value there, and there's a numerical value where c is. And this product is the difference of squares. So you multiply out the left side, which is a difference of squares. So you end up with a bunch of numbers and a z squared. You don't have a z term, so you don't need the quadratic formula. You solve a z squared, and then you take the square root, you get z. Okay, now, so from the first step, you get the average. From the last step, you get the z. Okay, so the roots are average plus z and average minus z. Done. Right, now, those of you who are paying attention are gonna say, wait, I have a question. I see this. You can't fool me, I see this. I see this part right here, where you have an equation with no a, or a equals 1. Yeah. I hear you. So yeah, what if the quadratic equation has an a that's not equal to 1? Well, how do you make it 1? Divide it out. Divide both sides by a. So yeah, if your given equation is 2x squared minus 3x plus 2, just divide by 2. And as a matter of fact, that's what I would do in my next video. I will do some more examples where a is not equal to 1, and also where the roots are complex numbers. Professor Lowe's method happens to also work when the roots are complex numbers. So yeah, just like the quadratic formula, it will work all the time. So thank you so much, Professor Po-shen Lowe. This has been awesome. And thank you very much for watching.